Good afternoon and welcome to our class for today. Today we want to discuss with you a very important aspect of statistics called time series. So what is time series? For us to comprehensively understand what time series is, we require to give some illustrations. And these illustrations are that oftentimes, perhaps, we had heard from people say that the price of a commodity has increased over the time. The price of a commodity has increased over the time. There are three key words here in this definition. One is price, two is over time, and then the third one is increase. So I have here, I'm having price, I have price, I have over time, and I have increase. I repeat the illustration I gave. I said oftentimes some people have heard people say that the price of a commodity has increased over time. Price of a commodity has increased over time. You may have equally heard people say that the extent of erosion over time at a particular place has decreased. Extent. Talk about extent. Talk about extent. Okay? Talk about what over time still. And talk about what decreased. Talk about what decreased. I repeat that illustration. That the extent of erosion at a particular place over time has decreased. The three key words still remain: extent here, over time, and then decrease, which is what I have on the board. You may have equally heard people say that the bank rates, or what we call the bank charges, has increased over time. Or better still, to use the illustration which you are used to better, that the extent of charges by the bank, or what we call the interest rates has increased over time. So here we talk about interest rates, still talk about over time, and then still talk about what increase. Okay? You may have equally heard people say that the movement of this ball over time has remained constant. People say that. So here I'm having what? Movement. I'm having over time, and I'm still having what we call constant, or what I might call stable. Okay. All these which I have on the board are all time series statements, where data are recorded on these parameters against time of their occurrence, with regards to either increase, decrease, or being stable. Therefore, one can categorically say that time series is defined as a set of observations that are sequentially recorded against time. That's what time series is. A set of observations that are recorded sequentially against the time of their occurrence. That's what we refer to as a time series. So anytime we record observations or record data or take measurement on any parameter against time of their occurrence, we regard such observations or data set as time series. So that is what we are going to tell you about a time series. We equally have what we call components of time series. What we call what? Components of time series. Components of time series. Component of time series. We are going to say a little thing here to be able to address the confusion that people have over the years had about the concept of the components of time series. A lot of people who talk about components of time series in reality do not know what components of time series what mean. And for that reason, let us have these following illustrations. Of course, you know that once you take down observations against what time, that these observations are not going to be the same. They are subject to changes, subject to variations. The price of a commodity this month might not be the same thing with the price of that commodity next month down the line. So the concern becomes, what are the reasons for these changes in the time series observations? Some people might preferably say, what are the forces behind changing the observations coming from this particular variable? Those forces that are responsible to changing the values of a time series is what we regard to as components of time series. So whenever you hear components of time series, don't see it as something that is coming from the sky or coming from the world, from the air. They are those forces that are responsible to making the values of what of a series to change over time. And then, of course, those components of time series are, number one, we have what we call a trend component. What we call a trend component. Trend component. Number two, we have what we call the seasonal component. Seasonal component. Seasonal component. Number three, we have, this is number one. Number three, we have what we call the cyclic component. The cyclic what? Components. Components. And then the last one being number four, we have what we call the random or irregular component. The random or irregular components. We want to make some statements here that are meant to equally address someone's likely misconception of going through some pages of textbooks and beginning to see where they are talking about components of time series and writing another thing different from what we have here on the board. Of course, this trend component is regarded to be the long-term movement in a time series data. The long-term movement of a time series what? Data. And then this seasonal component is regarded to be a short-term movement in a time series what? Data. And equally, this cyclic component is regarded as a short movement in a time series data. Because of this explanation, you find people say that the components of time series can be written this way. Permit me to clean here. That the component of time series can be written this way. Component of time series can be written this way. They have number one as component of time series. And they tell you the long-term movement. They call it the long-term movement. Long-term movement. And then number two, they talk about short-term movement. Short-term movement. Okay? Movement. And then the last being what I have here, number three, they talk about the random or what we call the irregular components. The irregular components. And of course, going by the explanation we had earlier on this component of time series, we have made you know that when they talk about long-term movement, they are referring to as a trend. So here is talking about trend. And then when they talk about short-term movement, they are making reference to the seasonal and cyclic components. So here I have the seasonal and cyclic components. And then the other one remains what we call the irregular components. We are going to look at them one by one. First of all, looking at the long term or the trend, looking at the short term, which of course amounts to looking at seasonal and cyclic, and then finally looking at the what we call the random or irregular component. So please permit me to clean here while we begin addressing them one after the other. So I clean this. Okay. When we talk about trend components, let me put it components, in time series, what do we mean? What we mean is that the trend is the general long-term average movement of the series. What you are going to underline in this definition is general, long-term, and average. We use these keywords to describe trend in time series. Okay? The general long-term average movement of the series is what we refer to as a trend. And this trend could either be increasing, or it could be decreasing, or it is stable. So that is what we are going to say about what trend, which of course are very wholesome. One, we should bear in mind that it is a long-term movement. It's a general movement of the average of what of the series, which of course could be either increasing, or it could be decreasing, or it can equally be stable. That is what we refer to as a trend. And of course, this trend can be identified in two categories. It can be identified in terms of what we call the linear trend and what we call non-linear trend. Linear trend, linear trend. And then what we call the non-linear trend. Non-linear trend. Okay? Which people can, of course, call the curvilinear trend. A time series trend is regarded to be linear if the plot of the observations with respect to time cluster around a straight line. That is what we refer to as a linear trend. When you plot the time series observation against the time of their occurrence, and the data points cluster around a straight line, we refer that trend to be what we call a linear trend. But when they cluster around a curve, which is not a straight line, then we are making reference to what we call non-linear trend. That's what we mean by that. So I want to believe you must have understood in totality what trend is, and then what we mean by linear trend, and then non-linear trend. Then we go over to what we call the seasonal component. What we call the what? Seasonal component. Okay? Seasonal components. When we talk about seasonal components, we make use of one particular keyword, and that keyword is regular or periodic. So, the seasonal component is the regular or periodic movement of a time series worth observations which span less than a year. I repeat, that the seasonal component of a time series is a regular or a periodic movement of the time series or of the series which span less than what, a year. So anytime we want to make reference to seasonal component of time series, we are looking forward to seeing the use of this keyword periodic or the use of this keyword regular. And of course, it must span less than 1 year. So for you to talk about the seasonal component in any time series worth data, it means that the data is recorded either one is recorded what, hourly. Two is recorded what, daily. Number three, it could be recorded what, weekly. Or it could be recorded, number four, monthly. Or it could be recorded what, quarterly, which is number five. And any other kind of time frame you can think about, but not yearly. Reason being that we said earlier in the definition that the span of the seasonal component is less than a year. So when we have a yearly data, we should not be talking about what, seasonal variation there. Okay? Because the seasonal variation now occur in less than what, a year. So when data is recorded yearly, we are not discussing the seasonal variation there. Okay? So permit me to clean here while we now go over and begin to discuss what we call our cyclic movement. Or let me still pen it down. Here, we are talking about the cyclic movement, or what we call the cyclic components. Okay? This one equally, of course, is the regular or periodic movement of a time series that span more than a year. So the major difference between the seasonal component and then the cyclic component is that while seasonal component is regular, periodic, spans less than a year, the cyclic component is equally regular, periodic, but spans more than what, a year. Of course, this cyclic component is often regarded to be a business cycle. It's regarded to be what? Business cycle. Business cycle. Why do we regard it as a business cycle? Because it often contains 4 phases. 4 what? Phases. Phases of prosperity. Phases of what? Prosperity. Prosperity. Phases of what we call recession. Recession. Phases of what we call, we equally have another phases there which we call depression. And then the phases which we call recovery. Which we call what? Recovery. Recovery. So that is why oftentimes we address this cyclic component as a business cycle, because it comprises of 3 phases here. Beginning from prosperity, season of prosperity, to recession, to depression, and then to recovery. So you permit me to clean the board while we talk about the random or the irregular components. The random or irregular components. Permit me to clean here. Okay. Yes. So we now talk about what we call the irregular or what we call the random. The random or irregular. Random or irregular. Of course, when we talk about the regular or the random or irregular components, we are making reference to those variations that, of course, are not predictable. They are not controllable. They are erratic. You can't control it in an experiment. It could be occasioned by war, it could be occasioned by earthquake, or whatever thing that can take people by surprise. So it is irregular, it is random, it is erratic, it's not something that can be controlled. These are what we call the components of time series. Okay? Now, before we go ahead, it is important we ask ourselves, why do we study time series? What does time series do for us? And in that case, we are now talking about the uses of time series. Uses of a time series. But before we go over to the use of time series, it is equally very necessary that we tell ourselves how time series is presented. We are now talking about presentation of time series data. Presentation of time series data. Presentation of time series data. Okay? The only thing, of course, we can hold with confidence in today's class is that time series data is a function of time. It depends on the time. That was why we said earlier, set of observations that are recorded against what time. So one can write time series to be that y subscript to what t is given as what f of what of t, a function of what of time. Time series can be given this way. Okay? But then, of course, you know that time series is often recorded against different time points. Let us call these time points T1, T2, T3, down to Tn. And in that case, of course, we are talking about time points, and these time points becomes what we call T1, becomes what we call T2, becomes what we call T3, down up to what? Up to Tn. That is to say that you come to the series. At time 1, you measure the parameter there. At time 2, you measure the parameter there down to time n. And in that case, that time series is going to be given, the observations of that time series will be given as what? This is y of t1, this is y of t2, this is y of t3, down to what? Y of t(n). And in that case, you are now saying, these are the time points. These are the measurements taken on that variable, particularly on a parameter of interest at these different points in what? In time. But because we already know that a time series is a function of what? Of time. Oftentimes, you go to textbooks or magazines and you hear them make reference to what? To time series without necessarily talking about what t, because it is understood that for you to talk about time series, you are talking about what? Time. And you can see them write something like this, talking about what? Y1, talking about Y2, talking about Y3, and then talking about what? Yn. Also making reference to time series what? Observations taken at these different points in times, time 1, time 2, time 3, down to what? To time n. This is how to present a time series what? Data. Okay? And before we equally go over to looking at the importance of a time series what? Data, we are going to talk about what we call the model of time series. Model of what? Of time series. So we clean here and talk about what? Model. Talk about what? Model. Okay, model of time series. Model of time series. Yes, model of time series. There are different kinds of models in time series, which of course anybody can use to study the movement or the variations occurring in that particular word series. We have what we call the additive model. We have what we call the multiplicative model, and we equally have what we call mixed model. So we talk about number one, we have what we call additive model. Additive model. We have number two, what we call the multiplicative model. Multiplicative model. Then we have number three, what we call the mixed model. Mixed model. Mixed what? Model. The question here begins from even what is a model? A model is a mathematical expression that represents real life situation. That's what a model is. Mathematical expression that represents real life situations. Remember that earlier on, we had identified four components of what of time series, which begins from trend and ends at what we call the irregular or the random component of time series. What if we write something like what? Capital what? T, T, to represent what we call the trend component. What we call the what? Trend component. And then we write something like what? S of T, to represent what we call the seasonal component. We write something like what? C of T, to represent what we call the cyclic what component, and write what we call R of T to represent what we call the random component. According to additive model, the model will be given as that y of t will be given as what? T of t plus s of t plus c of t plus r of t. This is what we call additive model of time series. And in this the additive model, there is one strong assumption here. The assumption here is that these components of time series act independently. They don't depend on each other. That is, of course, what must hold before this additive model will equally be valid. That the components of this time series are acting independently from each other. Then when we talk about the multiplicative model, we are having that our y of t is given as what? T of t multiplied by s of t multiplied by what? C of t and multiplied by r of t. This is what we call the multiplicative model. Okay? Which of course have an assumption that the components are not independent of each other. Okay? So, but when we talk about the multiplicative model, the multiplicative model says this way. For the multiplicative model, we have the multiplicative model. Sorry? The multiplicative model, we have it written this way. Okay? For your own better comprehension, there are different kinds of multiplicative model. And that's the reason why I'm bent to call up this particular one, which I have here, for you to see one of the multiplicative model. Because there are different assumptions surrounding the multiplicative models. So in that multiplicative model, we have that y of t can be given as what we call t of t plus s of t multiplied by c of t multiplied by r of what? Of t. There are so many others. The only good news here is that in the mix is making use of additive and is making use of what? Multiplicative. There are so many other mixed what models which we can have. So we have only discussed three models here. One, additive model, two, multiplicative model, and three, the mixed what model. Then we now go over to looking at the relevance of time series, uses of time series while we study time series. So permit me to clean the board and then we discuss that in together. So permit me to clean. Okay, we are talking about use of time series now. Uses of time series. Of time series. Number one, for us to understand the uses of time series better, we are going to make the following illustrations. The time series data on its own, which you are collecting, comprises of even the observation from the past up to the what, to the present time. And when you look at the behaviors of this data from the past to this present time, you might likely begin to think the way that that series is going to behave in what, in future. And this statement which I have made here in time series analysis is called predicting of the future behaviors of what, of the series, which is the number one importance of what, of time series or use of time series. To predict the future values of the what, of the series. Number one, to predict. To predict. Some people don't use this word predict, they use the word forecast. Forecast the future values